Welcome back, ladies and gentlemen, guys and gals. We're joined here today, and you have Travis Spivey and his son Jordan Spivey. And today we're going to talk about covalent and ionic bonds. So let's get to it. In a covalent bond, they share electrons. How do we know they share electrons? Because if you look at the root word or prefix, you have co-champion, co-captain, cooperate, collaborate. Co stands for to share or to work with. If you look at the next one, ionic bonds mean to give or take electrons. Now, the last video we talked about what creates an ion is going to be an element with a positive or negative charge. So now let's start off with our covalent bonds first, since they share electrons. The most famous covalent bond ever is going to be H2O. So I'm going to draw the Lewis dot structure for H2O, which is going to be one hydrogen on the left hand side, and hydrogen has one valence electrons. How do I know? Because you can look on your periodic table and see that. And then oxygen has 6 valence electrons. Once again, you refer back to your periodic table and it will show you. And then our next hydrogen on the right also has 1 valence electrons. So now all elements want to be stable. So they want to have, most elements want to have 8 valence electrons. So oxygen is trying to get 8 valence electrons while hydrogen is trying to get 2. Hydrogen and helium are exceptions to the octet rule. Why? Because in their first energy shell you only need 2 valence electrons. So if we look at it, they are going to share these 2 electrons right here, and they're going to share these 2 electrons right here. So let's see if both of them have satisfied the octet rule. Well, if I look at hydrogen right here, it has 2 valence electrons, which is great because in that first ring you only fit 2. If I look at oxygen has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. And then I look at my other hydrogen, it has 2 valence electrons as well. So this covalent bond satisfies the octet rule. So now let's look at our ionic bond. We're going to give or take electrons, and I'll change it up a little bit. Instead of putting sodium chloride, which we always do, let's do lithium. Let's do Li, lithium oxide, Li2O. And I'm going to show you and explain to you why there are 2 lithiums and only 1 oxygen. If you look on your periodic table, lithium has 1 valence electron. So each lithium is going to have 1 valence electron. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. Now, since it's an ionic bond, it's going to be a bond between a metal and a non-metal. Covalent bonds are bonds between 2 or more non-metals. Now let's go back to our ionic bond. Since it's going to give or take electrons, guess what lithium is going to do? Lithium is going to take this valence electron and give it right here. And it's going to take this valence electron and give it right here. So if I drew the Bohr model for it, you will see that lithium now only has 2 valence electrons in its outermost shell. Oxygen has 8 valence electrons in its outermost shell. Each lithium is going to get a positive 1 charge because they have 3 protons and now only 2 electrons. And each oxygen is going to have a negative 1 charge. It's going to have a negative 2 charge. I apologize about that. So it would have a negative 2 charge. So plus 1, that's positive 2. And then I have this negative 2. And guess what? These 2 charges, they cancel or they cross each other out. So the biggest difference between covalent and ionic bonds, covalent bonds, they share electrons to satisfy the octet rule, while ionic bonds give or take electrons to satisfy the octet rule. Ladies and gentlemen, thank you once again. I am Travis Spivey, joined by my son
Jordan Spivey.
And peace, we're out.